Hey guys, happy Tuesday. So before we jump into today's material, I just wanted to make another plug for office hours. The office hours for my class are on the schedule that Miss Jacobs posted with everyone's office hours. They are from 12 to 12:30 on Tuesdays and Thursdays, giving you enough time to get started with the math and then come and ask your questions and then finish it up. I had a student attend office hours last week who had a lot of questions for me and I answered them, and she then got a 100% on the quizzes activity on her first try. So, it's a really great resource for you. If you have questions, that is the time that you need to be coming to get them answered. If you scored less than an 80% on that quizzes assignment, that should be a flag to you that you need some help, and I would really love to see you at office hours. All right, so moving on, we're still obviously in our probability unit for 2 more weeks, this week and next. This week we're talking about theoretical probability. So when I say theoretical, I mean things that are happening in theory, right? All probability is theoretical until it's actually, until we actually conduct the experiment, and then it's no longer probability, it's just something that happened, right? So probability is the measure of how likely an event is to occur. The set of all possible outcomes is the sample space, and when we are writing out our probabilities, we usually do so as fractions, and that would be like the denominator. Oh, that was not pretty. Okay. So for equally likely outcomes, the theoretical probability of an event, P of E, so the probability of an event, is the ratio of the number of favorable outcomes to the total number of outcomes possible. And that might sound confusing to you, but all it means is that it's a ratio, so we can express that as a fraction, right? We talked earlier this year about ratios and how we can write them like this or like this, right? Doesn't really matter. Where A is the number of favorable outcomes and B is the number of total outcomes possible. All right, so I'm going to give you a really simple example just to start us off, kind of as a reference point throughout this lecture. So if I say, what is the probability of rolling a dice and landing on 1? Well, then you would say that the number of favorable outcomes is 1, right? Because we're talking about a standard dice and there are 6 sides, right? And only one of the sides is a 1. And the total number of outcomes is 6, right? Because there are 6 possible things that could have happened, but 1 is only one of them. Versus if I were to say, what's the probability that I land on an even number? Well, it's no longer 1 out of 6, right? Then you have to ask yourself, well, how many even numbers are there on a dice? Well, there's 6 numbers, 1 through 6. 3 of them are even. There's 6 in total, which is 1/2. Right, so that's all simple probability is, right? So simple probability is the probability of one event happening. And some of these questions might appear to be more complicated, but really that's the heart of it. Okay, so number 1, a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So before you can create your ratio, you first need to know how many total marbles you have. And that information isn't explicitly given to you, but of course you can very easily find it. You know that you have 32 and 28, so together you have 60 marbles. That is your total number of possible outcomes, right? That's like our blue denominator number. And our numerator needs to be the number of favorable outcomes. Well, favorable in this case means a marble that is red. And we're told that there are 32 marbles that are red, so it's 32 over 60, which of course we know that we need to simplify, giving us 8 over 15. That's the probability that in this case we would select a red marble. Let's just do a couple more of these. The simple probability ones, as the name suggests, are pretty simple, so I don't want to do all of them with you. All right. Let's try number 3, just because some of the prime number ones are going to come up in your homework, and I want to make sure you know how to do them. A day in the month of January is randomly selected. What is the probability of selecting a prime number? So let's address the first part first. A day in the month of January. Okay. Well, if you do not know how many days are in the month of January, you have a very great advantage right now, and that is you are sitting at your computer. So I need you, obviously I'm going to do this problem with you, so not in this case, but if you were doing a question and you didn't know how many days were in that month, right, just look it up. Please do not say you can't do the question because you don't know how many days are in the month, right? So there are 31 days in the month of January. That would be your denominator. And our numerator is the number of prime numbers between 1 and 31. So I am not going to do all of this out for you because knowing prime numbers it's something you should know. However, I'm going to tell you that there are 11. And if you don't know, well, first of all, if you don't know what a prime number is, look up what a prime number is. Second of all, you can look up a list of prime numbers and you will see that between 1 and 31 that there are 11 of them. Different story for a different day. I just wanted to flag your attention that there's going to be questions like this, and you need to make sure you know what a prime number is. Okay, so between 1 and 31, there are 11 prime numbers. So the probability of, in the month of January, us being on a day that is a prime number is 11 out of 31. And there's no simplifying there. All right, let's do 2 more. Let's do 5 and 6. Number 5, what is the probability of drawing a heart or a club from a standard deck of cards? So, how many cards are in a standard deck? 52. And we know that there are 13 of each type, right? There's 13 hearts, there's 13 clubs, 13 spades, etc. So when we have the probability of a heart or a club, that's 13 plus 13, which is 26. Of course, if you just knew that, that's 1/2 because there are 4 types of cards and this is 2 of them, you could have done it that way, right? 1/2. Number 6 is a fun one. It says there are 8 books lettered A through H on the shelf. If Scott randomly chose 2 books, what is the probability that he chose A and B? I'm going to let you think about that for a second before I answer it for you, all right? Because this doesn't really look like the other questions we've done so far. There are 8 books lettered A through H on the shelf. So think about that, right? Think you have a shelf and there are 8 books. You have 1, 2, 3, 4, 5, 6, 7, 8. I clearly did not draw that well, right? A through H. And we're saying if Scott randomly chose 2 of them, right? What's the probability that he chose A and B? Well, this is actually a question that combines simple probability with a combination, all right? Because here there are 8 books he could have chosen from, but A and B are specifically 2 of them. That's not just 2/8, because 2/8, 1/4, right? Like when you actually think about like the probability, he's not saying I'm just choosing any of the 2 books, right? It's specifically A and B. So that is 1 over the combination where you have 8 books, you're choosing 2. And when you plug that into your calculator, it's 1 over 28. So the probability of specifically choosing A and B is 28, 1 over 28. All right, that's different than just saying the probability of him choosing, 2 of the books. Okay, moving on. Now we have the complement of an event. The complement of an event is the probability that that event does not happen. The probability of the event not happening. Since the sum of all probabilities in a sample space is 1, the probability of an event not happening, so that's P of not E, is 1 minus P of E. So let me explain that. So when it says that the sum of all probabilities in a sample space is 1, what that means is, okay, so let's go back to the dice analogy. If I said, what was the probability that you're rolling a dice and you get a number between 1 and 6? Well, we're talking about, again, a standard dice that has 6 sides, 1 through 6. The probability of you getting any side between 1 and 6 is 6, right? 6 out of 6. 6 out of 6 is 1. If I say, what's the probability, let's look at number 3 here. A day in the month of January is randomly selected. What is the probability of selecting any day in the month of January? Well, it's 31 out of 31, which is 1, right? So that's what it means when it says the sum of all probabilities in a sample space is 1. And the probability of an event not happening is 1 minus P of E. So if we're talking about the probability of rolling on number 1 on a dice, then we could say, well, what's the probability that you don't roll on number 1? So if the probability that you roll on 1 is 1 out of 6, then the probability that you don't roll on 1 is 1 minus 1/6. So that's 6/6 minus 1/6, which is 5/6, which makes sense, right? Because there's 5 other sides to a dice, and the probability that you roll on any of those 5 sides is 5 out of 6. Okay, so the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? Well, that's everything else, right? There's not an in between. There's not like it kind of snows, it kind of doesn't. It either snows or it does not. So that's 1 minus 7 over 20. Remember, when you are operating with fractions, you want a common denominator. So you're going to change that 1 to 20 over 20 minus 7 over 20. So now you just have to subtract the numerators and get 13 over 20. That's the probability that it's not going to snow. All right, a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? So 1 minus, well, first we need to think about how many months begin with the letter A. So I'm not going to go through all the months right now, but just think about them in your head, all right, and then join me when you're done. Okay, 2 months, right? April and August. Those months begin with the letter A. So if we were just asked about that, that would be 2/12, right? But because this is a complement, it's 1 minus 2/12, which is 12/12 minus 2/12, which is 10/12, which of course we want to simplify to 5/6. All right, I think we're good here. We are going to move on to compound events. This would be a really good place, by the way, to stop if you want to break this lecture up. So we have simple events. By the way, complement of an event is a simple event. It's still the probability of one thing happening. And then compounded events is different. So this is a good stopping place. If you're sticking with me, great. Okay, so the compound of an event is just the probability of 2 or more simple events. So just multiple things happening. And within compounded events, we have 2 types of subcategories. First is independent events. That's when the outcome of one event does not affect the outcome of the other event. All right, so I'm going to give you another dice example. All right, what is the probability that I roll a dice and I get a 1, and then I flip a coin and I flip on heads? So ask yourself, do those 2 things have anything to do with each other? Does the outcome of one event impact the other event? No, right? Rolling the dice has nothing to do with flipping the coin. So that would mean that the probability of A, we could say that, is 1/6. That's the probability of landing a 1. You just multiply by the probability of flipping a coin and getting heads, which would be 1/2, right? So the probability of both of those things happening would be 1/12. All right. Then we have dependent events. This is when the outcome of one event does affect the outcome of the other. So I'm going to give you a different example. let's pretend we're all in the classroom together and I have a cup that has your name on popsicle sticks. And let's say there's 25 of you in my class. All right. What's the probability that I pick a name out of the cup and it is your name? Well, the probability of that happening is 1 out of 25, right? There are 25 names in the cup. You are one of them. That's 1 out of 25. Okay. Then just because I'm a nice, fair person, I'm going to take your popsicle stick and remove it from the cup so I don't call on your name again. Then what's the probability of your friend's name being called? 1 still, but out of not 25 anymore, 24 now, because there's only 24 names in the cup because yours is gone, right? That's an example of dependent probability. When the outcome of one event does affect the outcome of the other event. So this is still the probability of the first event multiplied by the probability of the second, but not just the probability of the second, it's the probability of the second after A occurs, right? Because the probability that I take your friend's name out of the cup, if we were just to ask, just in a simple probability world, independent of your name being selected, just I'm picking your friend's name, well, that would be 1 out of 25, right? It's only 1 out of 24 because I already took your name out. Okay, so that's what it means by B after A occurs. Really important that you're paying attention to the question, though, because if I had said, I have a cup of popsicle sticks, I take your name out, but then I put your name back in, and then what's the probability that I take your friends out? Well, that would still be 1 out of 25 because, the total number of names in the cup is still 25, right? So you just have to pay attention to the question. All right, so let's try a couple independent ones. I'm going to, let's do number 12, and then we'll do like this kind of whole set down here because these are really good. Okay. Number 12, a coin is tossed, then a day of the week is selected. What is the probability of getting tails and then getting a day starting with the letter T? Okay, so first, what's the probability of getting tails? Well, 1/2, right? Because there's 2 things that could have happened. Obviously, tails is just one of them. And then we want to know the probability of getting a day starting with the letter T. So day of the week. Okay, how many days in the week start with T? 2, Tuesday and Thursday. Out of 7. Okay, so you're just multiplying those 2 things. They had nothing to do with each other, right? The first had no bearing on the second. So you were just multiplying across the numerator and denominator. So 1 times 2, 2, 2 times 7, 14. Of course, we simplify and we get 1 out of 7. All right, now on to this crayon set of questions, which I really like. A bag contains 8 red crayons, 14 purple crayons, 6 yellow, and 4 green. A crayon is selected, replaced, and then another is selected. Find each probability. All right, well, before we go any further, let's first find out how many total number of crayons we have, because that's obviously going to be very important to us. So you just need to add up the 8, the 14, the 6, and the 4, and of course you're going to get 32 total. All right, so really important, guys. This says that the crayon is selected and then replaced. So for number 13, what's the probability that we pick a purple crayon and then pick a yellow crayon? So independently, just if it was a simple probability question, right? The probability that we get a purple crayon is 14 out of 32, right? Because there's 14 purple crayons, 32 total crayons. Okay. So we take that purple crayon, we color with it. Then we put that crayon back in the bag. And we want to know the probability that we pick a yellow. Okay, well, there are 6 yellow crayons. And how many total crayons are there in the bag? Still 32, because that purple one has been put back. So it's 14 times 6 over 32 times 32, right? So when you do your multiplication and you simplify, you get 21 over 256. And if you're like, well, that's not what I got, simplify. and then it will be if you did it correctly. All right, green then red, same thing here, right? 4 out of 32, you put it back, so we still have 32 crayons. And then red, 8. Multiply, simplify, 1 out of 32. 2 purples. All right, you have 14 out of 32. And then you put it back, another purple, still 14 out of 32. Multiply, simplify. And then 2 yellows, same deal here, right? 6 out of 32. And then again, 6 out of 32. Multiply, simplify, the end. All right, now the story changes a little bit because it says, using the same example from above, assume once a crayon is selected, it is not replaced, because apparently it is like a toddler who's using crayons here and does not put them back. Okay, so the probability that you select a yellow crayon is 6 out of 32, right? But then what's the probability that you select a red? Well, there are 8 crayons, but there's not 32 crayons. There's only 31 crayons, which increases the probability that you're going to select a red, right? Because there's less to choose from. That's where that 31 comes from. All right, so multiply, simplify, 3 out of 62. Purple then green. All right, there's 14 purple crayons out of 32 crayons. There are 4 green crayons, but there's not 32, there's 31. All right, 19 and 20 are fun. 2 reds, all right, so 8 out of 32. And then you might be saying, oh, well, then the next one is 8 out of 31. No. When you take that red crayon and do not put it in the bag, how many red crayons are there left? Only 7. 7 out of 31, right? There were 8 red crayons, but you took one and you did not put it back. Now there are only 7 red crayons left, 31 total crayons left. You really, really have to pay attention. Same thing for the 2 greens, right? Your first green is 4 out of 32, but then you don't put it back, so your second green is 3 out of 31. And again, my answers here are all simplified, so make sure you're simplifying. All right, just for fun, let's do these last 2, and then that will be it for the day. A card is drawn from a standard deck, not replaced, and another is drawn. What is the probability of choosing a heart, then a spade? All right, so there are 13 hearts in a deck of cards. If you don't know this, guys, Google is a great resource, all right? So there are 13 hearts, so 13 out of 52. But then you don't replace the card and you want to know what the probability is that you choose a spade. Well, there are still 13 spades, but there's only 51 cards total. 13 out of 204, number 22. Jack had 4 Snickers bars and 8 Mars bars. He randomly chose a piece of candy, ate it, then chose another. What is the probability that both candy bars were Snickers? Well, this one doesn't say whether he replaced it or not, but use common sense here. He ate it, right? So he's obviously not replacing it. So don't always just look for the word replaced or not replaced, right? He ate it. It's obviously not going back. So he had 4 Snickers bars and 8 Mars bars, which means in total he had 12 candy bars. The probability that the first one he chose was the Snickers, well, there's 4 Snickers, so 4 out of 12. And then the second one, right, well, there's only 11 candy bars left, and there's only 3 Snickers because the first one was a Snickers. So, simplify, that's 1 out of 11. Okay, so that is it for today. Make sure you are completing these 2 pages that are the homework for our theoretical probability. Make sure that you take a picture of your work, not just of the answers, but of your work as well. And that is posted on this assignment by Thursday morning at 8 a.m. when I go through and check. If you have questions, I need to be seeing your face during office hours. and I hope you all have a wonderful rest of your day.